Okay, so I'm happy to welcome you to my presentation about the topic PLM, ERP, MES and CRM, a new perspective, a new universe, and I will show how this all is working together and will working together in the future. So let's start with a timeline. We have here a timeline and it starts 1980 until 2040. It's about 60 years we will have a look at, and we will now zoom on today, where I discuss here with you, where I show you this kind of presentation, and I will go back to 2030. Why? There was something special I want to show, and it's a base for the whole thing, because I started there to discuss about these topics called Industry 4.0 came up anno 2013. And the typical question was, Industry 4.0, well, have you heard yet? And then the heroes out of the production said, this is just hot air and old wine in new bottles, as we say in German. And we have done these along since 15 years. And once again, a big fuss is made. So this was in the time 2013, and I remember a colleague of mine then told me, Jörg, have you heard about cyber-physical systems and cyber-physical production systems? And as I heard that, I think, this sounds so crazy. I cannot tell it to my students because I think Professor Fischer is totally crazy. Anyhow, this changed completely, and Industry 4.0 was really focused at the beginning, focused on production and digitalization in production, which was a really too narrow space. So it was really limited to the horizon. And the good thing was that it changed. And we go back today and what happened in between. So the horizon has broadened, it was much wider, and we got other buzzwords which are much more important because they are not only focused on the production. So we have, for example, the discussion about new business models. We had the discussion that the products get much more clever, that they are smarter, that they, let's say, are things which are connected to the internet. We had the discussion about individualization, which is nearly connected to Industry 4.0. We have the industrial data science and all these stuff. And things changed a lot in industry since we start this discussion, and it started with these kind of pictures. Maybe, or I think you know or remember this picture and have seen it already in presentations. So it's a typical example for digitalization. We have here the election of the Pope in 2005. It was Cardinal Ratzinger at the conclave. He died last year. And then there once Steve Ballmer said, there's no chance that the iPhone is going to get any significant market share, no chance. And then in 2013, in the next conclave, we really see this picture, and this was a complete change. And I remember, as I first have shown this picture, really it was a mindset change within the audience, and it was, I think, a very, very important mindset change we got there. Okay, and then 2020, another thing happened. You see here the Black Swan, and we discuss about Black Swan events, meaning current events which are really not foreseeable. So we had one 2020, the pandemic. We had it 2022, which was the war in the Ukraine. And then we started to talk about multidimensional disruption, meaning not only one disruption, so multi-dimensions which are pushing to the companies, and that the companies needs resilience. So meaning that they are focused, that are prepared from changes which are coming out of nowhere. So this is a typical problem. And this absolutely changed the consultant tongue. So in earlier times, consultants were really, let's say, conservative, spoke straight, and now it totally changed. They totally tell us complete other things. And here's example, and I really heard a similar thing at a customer currently recently. So if we define, so it's what the consultants say, suitable package business capabilities, combines them with some blockchain, artificial intelligence, and machine learning, then we can implement resilience in the company through a low-code platform. Oh, it's not stop. So then the departments then develop individual solutions. We can easily integrate these solutions via middleware with a suitable data representation layer. Then a fully automated connection to the EBOM in PLM with a KMAT-based MBOM in ERP would be possible. And this could also be provided to MES. Great. What do you think? And we need to use an in-memory graph database as foundation. So let's quickly set up a POC and implement this with agile methods. What do you think? Sounds really great, right? And it's really great. And is this true? We do not know. And I will show you how PLM and digitalization architects see this and how it feels for them. So you see this picture. I made it as I was with my wife and my young son in a safari park. And imagine it's for PLM architects the same if there would somebody say, oh, this big crazy bird has kicked out the cow out of the nest and stole the eggs. You don't believe it? I have a proof. Here, you see the picture of the poor cow. And you see, if such a business consulting is coming, then for typical PLM and digitalization architects, it's like here Captain Picard in Star Trek. It's really crazy. And at this point, and at this discussion, it's so complex, we have so much buzzwords, that it's necessary that we put the reset button here. Okay, and I will start from scratch. I will start to give you a real new perspective. I will tell you how it's really the way was and how we digitalize companies and what this means. And I promise it's like a roller coaster ride. We will go deep in details. We will go up to the future and all this stuff. So please be prepared. We will start now. Okay, let's start at the beginning. The question is, how can we depict a company in a digital model? And to answer this, we have to think, or let's say, go in a system thinking. So what does system thinking mean? Let's say we draw these boxes and say these are systems, we say the company as a system, and we see the market and the business partners of the company also as a system. And what we are doing then is we subdivide the things in a company in different architectures. So we have a process architecture, and the process architecture subsum all what we have in the processes. Then we have a process control architecture, and you find it really, for example, in an SAP, there are control levers which are really switched during the processes. And we have an organizational architecture, and we have an information architecture. And these different kinds of architecture will carry the product and service portfolio. And they are only needed because we want to produce and sell and offer the market our product and service portfolio. That's it. And with the help of this architecture, we can go deep in a company and understand exactly what they are doing. So what would the recommendation be of the business consultant? He would say now, hey, it's no problem. Just let's make a process analysis and we will see. But this is not true. Let's listen only to the PLM and digitalization architect, and he will say complete other thing. He will say process architecture will not uncover the secrets of a company to us. If we want to go really in the secrets, let's have a look in the information architecture, and this is what I want to do with you together. So on the question we will follow up now is, when have we started to depicting companies digitally? So when we started, and let's go back in time, there was around the 80s the SIM concept, computer integrated manufacturing. Then we had the CAD, and then there was a point in time which was really important. It was the day R3 from SAP comes out. It was a real game changer. It was a so cool system, and you could really depict the different plants, the different sales organizations, all these stuff, and you could depict complete enterprises within the systems. And how is it done? Let's look how this is done. So imagine this would be a company. We see the real company or digital company on Google, and we go deep and say which kind of data records we need. So we need organizational data, we need master data, we need transaction data, and we need control data. So let's have first a look on the organizational data. What does it mean? So if you look in an SAP book and you would do this, you find pictures like this, and it's so complex. Let's put it again. Nobody wants to understand the whole thing, and the team leaders from the business say, I don't care about this, IT, please fix it. But it's very important, and let's say we have the layer of the real world, and what we find in the real world we have to depict in the digital world. And for this we need organizational objects which depict entities that are real or process relevant entities of a company. So what does it mean? So we have plants, we have to depict the plant. We have sales organizations, so we have to have objects for sales organizations. We have objects for MRP area, storage locations, purchase organization. That means we depict real entities within the system. So that means we have objects to depict an organization in a digital model, and then we have another thing. The technical guys, which may here be also in the call or see this, forget them typically. So we have the layer of the real world legal structure, the legal entities. That means we have legal entities and we need to depict the legal entities. And for this, there is an SAP something which is called in German Buchungskreis. I like this word very much. In English, it's company code. That means every legal entity which has to prepare an annual financial report has to have a company code. And then all cash transactions are booked towards a company code. So you see, for the legal entities, you also need something. This is organizational data, and we will just make it very easy and bring this on one level. And you can see there is a CFO, and the CFO said, then if we want to be successful, we need an ERP. We need an ERP, and it was for him a complete game changer. All things changed. So let's accept there is such a layer. So let's go to master data. What is master data? So in the end, we need, so that the ERP can run, we need a skeleton of master data. You can see it's really like skyscrapers. You need them so that people are going in and out and do business in them. And it's, let's say, nearly the same with the transaction data or with the ERP. The main task of the ERP is really pulling processes through, let's say, this skeleton, and this skeleton is the master data. And I will show the master data you need for this. So we have the material as a part, and we have the material as a raw material, and an assembly, and a product, and a customer product, and we have a BOM, because the most important thing is the MRP run in the SAP. So we have the MRP run, we have the operations within the work schedule or the routing, we have the resources for every operation, and we have a customer, and the customer buys a product, and we have for sure a supplier, and the suppliers deliver something, and we have something important, which are the documents or the document, and the documents are describing the material. And what is important? These are is the master data the SAP or the ERP system needs, and it needs only rudimentary, let's say, low-level master data you need. And this is important. We need not all detailed master data, we need just something that, let's say, the machine is running. So this is what we have. We have master data. So let's do it easier. We forget for now all this legal stuff. We concentrate on the organization. And there is another special thing which is often forgotten if we look on master data. So master data has a connection, a linkage to the organizational layer. Why? A customer is buying a product at an organization, a sales organization, or a product is produced in a plant, or a product is, let's say, stored in a plant, and so on. What does it mean? Every master data in an ERP has to have a linkage to the organization object, and if it not has it, let's say the machine does not work. That means, and this will be important later for us, that we need a level of master data in organizational context. And then we have the transaction and the control data. We will put these things together and we will have a look on it. And then we can imagine that the ERP is a processing machine which brings processes through it. It starts with a customer order. Out of these customer orders, the MRP run generates a production or manufacturing orders and also orders to the suppliers. This is what the machine is doing. That it can run, it needs the organizational layer, it needs the master data layer. That's it. Just simple. And to be very clear what happens there, we look really and think about we are 1993 in the real world and in the digital world. And in the real world we have a real shop floor, we have these trucks which are bringing goods back and forth, and we have something important in the real shop floor. It is printers. We have printers in the shop floor. And why we need printers? Printers are the interconnection between the real shop floor and the digital world. And how is this working? We have some, I call it summarize or aggregation levels in the skyscrapers in the master data. For example, the sales order. The sales order has some positions, and the positions have a linkage to business object, which in this kind is the material which you buy, the products you are buying. You know this from SAP, it's common. And then from there a process is running through, and this process has transaction and creates transactional data, receipts typically. And if we have such a receipt, so the customer order, not the customer order, the manufacturing order is one, this receipt goes to the printer, and at the printer it's printed out, and then Tommy comes, take it, and starts working. And that you see how this is working, I have an example. So this is what's really printed. This is, for example, production system where it goes in, and you have to, let's say, put material, raw material, parts for your product out of it. This is be done. And that you can generate these orders, this is what an ERP is doing. You can do nothing within a production without you have, let's say, the okay from the ERP system. Okay, and then Tommy is doing something. And after he has done it, we bring it back, we bring the response back and say, ERP, we have done it. And then the ERP is booking cash to an internal account. That's the whole thing. And after it, and this is maybe also important, the process which are running through the ERP need control levers so that we can say it goes left or it goes right, like a train. And the ERP is full of such levers which are control how the process flow is going on. So this is what an ERP system is doing. It generates these responses, which receives the transaction data, and then books something somewhere, puts the orders out, puts the order together, and that. That's it. Okay, so if we have this, we can put this transaction layer in, and now we can simplify our picture. We have simplified it. We have the master data in organizational context, transaction data, and organization object entities that are real or process relevant. And this is ERP. Okay? So, and now we can say and put that together. I have written it down that I can read it, and it's a very clear sentence then. The essential task of an ERP system is to initiate process and document their initiate processes and document their fulfillment. The process in focus concern quantity and value flows, thereby the formal documentation of the fulfillment of the processes and the accompanying quantity and value transactions are in focus. Okay, you see and you can imagine ERP is a machine which puts orders through the whole system and documents a fulfillment. That's it. And the master data we need provides a necessary skeleton for this task. Let's go back in time. This was revolutionary. Really, we have overall the ERP, often it's the SAP in companies. And then there was a PDM. And the people said, engineering will do PDM and why? And the problem was another thing. So we learned in the universities that master data is stable over a long time. But this was not true for the documents, because the documents have revisions. So since documents have revisions, there's change on data. And this was really painful for the engineers. So the engineers ran to the CFO and said, we need PDM. It was PDM. And he said, that bit of master data, they are all stable and never change. We are doing it all in the ERPs, no problem. And it's a lot of cheaper. And you see all the departments was really sad about this. But the CFO has typically the IT, and the IT is underneath the CFO because it was a cost factor. So this was the classic ERP-driven view. Okay, but in the end, the engineers succeed in getting the PDM for the cut. And then there was Digital Factory and all this stuff, and then PLM came. But this was not the initial thing. After it, around 2013, we had a boom. Why? Just simple. There was so much topics which are coming in little or tied up. Forgot the words. So there was so much thing which really come bam bam bam. Do it, do this, and there was much pressure. It was a real storm that is coming, and I will explain it. This was a real turn of time. Why? It was a storm of a new technology. Everything is changed, and all these buzzwords I have discussed about can be seen as monster waves in this storm. And what is important for a company, you can say, oh, this and this wave will never hit me. Then you say, so then don't prepare for this. But if it hits you, then you are dead if you are not prepared. So you have the problem, you should be prepared. And the question is, how can we prepare on all these things and on which we have to be or for which we have to be prepared? And we can go in this and say our company, the system of a company, we can see as really these ships are sailing on these monster waves. And the question is, what can we do? And there is a sentence from my friend Christian Wotzka, and I like it very much. This is the reason I have it here. And he told me once, Jörg, a product only acts as a physical manifestations of the power and potential, meaning the ability to perform of a company. And if you will say, you will prepare your ship for the storm, the simple question is, what means ability to perform for your company? And we need the ability against these buzzwords, and I will show this. Let's start with individualization. Why? A promise of digital industry 4.0 was to really manage individualization. And let's have a look on it, and there's a key promise of digitalization and industry 4.0. And this is to be able to offer highly customized products in delivery times and the price of standard products. So, this is now our goal, and now let's have a look on it. To do this, we have to have a complete new interconnection between the main processes of the company. Let's have a look on the main processes. We have the process which I've drawn in blue, which is a design to SOP or handover or operate, meaning everything engineers are doing for the product. Then we have the lead to quote and the order to cash. This is where the sales sells the product and the production is started. And we have the process, the plan to produce and the purchase to pay, where it is produced and the production is organized. So these different process groups have an interconnection, and this interconnection is controlled by process patterns. And in earlier time we said process patterns are something strategical, meaning we put them once and then they are valid forever. But this has changed. We have to be agile as a company, and that means we have to be the ability, or we should learn to change these process patterns. But first of all, let's look on this process pattern. We start with the inventory strategy, and there we have the make to stock, the sample to order, and the make to order. You know it from the ERP. And this process pattern, you have to choose which one you want to have during the introduction or the implementation of the ERP. But in the future, you have per product group to, let's say, switch between. So you can say these product groups goes good at the market, we have to produce this on stock, we will make to stock and really create a production program and put this on stock and sell it from stock. And you can say, oh, now they don't work so good, we will switch to make to order. And you should switch, you should be able to switch it whenever you want. So this is the one thing, but we have another thing, and this is also very important. If we want to create individual products very fast, we have to connect the design process, the engineering process directly to the supply chain. And what does that mean? That means that we need process pattern of order processing. This is the engineering to order. And let's look on the engineering to order. In the engineering to order companies, there was a design process included in the lead to cash process. They do not know what a PEP is, what a product development process, all these things they do not know. So they do it let's say something nested within the ETO process. And you should know such an ETO process is needs a very long time. Very long time means, for example, 2 years. And if you now look on how the bombs and the engineering data is created, you have tons of time. So this is the reason why we typically have what I call the artist hero fairy principle. I will explain it. So we have first of all the artists. The artists create something cool, and in the end of the creation process, if you are lucky, they will do such a bomb excellence. Say, so this is my bomb, just do something with it. And then you have the heroes in the production. The heroes will fix all the problems you have. The manager never sees the problems because you have the hero. And everybody knows the name of the heroes, which are really fixing the whole thing. But what we often forget are the fairies. The fairies are in between, and let's say like magic, the data from the PDM goes down in the PLM. And since it is very easy and we have time, you can do this very good part-time. Meaning you get every day a list of materials and you call and say, what are the attributes we have to do and what kind of material it is and how it will produce. And then you put it all together in the ERP. So this was in earlier times. So let's go on the next process pattern, the select to order. And we will see it's the same. We will complete decoupled design process to our lead to cash process. And after we have designed it and we have the start of production, we sell and sell and sell and sell, and we don't care. Engineering is not anymore connected to the lead to cash process or to the follow-up process. And that means we have the same situation. We have tons of time. We have this. Why we have this? Just simple. During the product development process, all the bombs and all the data is created, and these data is created on the same way we have had in the ETO. And this was the classic old PLM implementation we had. But this has changed completely. Why? Because there is this promise of digitalization that we want to have customized products and that we want per order to have some customizing in it, but we want to have it with a very short lead time, with a very short delivery time. And this is just the reason why everything changed. So we have the product development process about the whole time. And if there is an order, we have in shortest time to, let's say, supply the data from the development process directly in the supply chain. And we are not talking from years here, we're talking from weeks, we're talking from days. So we really bring this together. And believe me, this interaction in the CTO Plus processes is extremely complex, and it is necessary that you are perfect in doing this, because if you are, then you really can, let's say, fulfill the promise of Industry 4.0. Just simple. And to do this, you have to discuss about E-bombs and E-bombs 150% or maximum bombs. You have to discuss about the E-bomb 100%, and you have to discuss about the M-bomb, and you have put the M-bomb directly within the ERP. This is the reason why we discuss about E-bombs and M-bombs and C stuff, because we have to deliver information directly to the supply chain in very, very short time. Okay. To subsum this all, process patterns specify how the main processes in company are suitably linked and how they interact. So the dynamics of the market and the need to implement resilience in the supply chain requires the ability to adapt the linkage of the main processes in the future depending on the current market environment. That means we have adjusted the buyer as well as the supplier mark on order and ad hoc. We have really changed the things per order, and this is completely new. And for this, you have really to put data directly in short time from the design layer within the supply chain. And this is completely new and has to be orchestrated. Okay, so, and just to know it, there are a lot of different cases in between these two processes. We know all these cases really. I did research over years how they are working, and believe me or not, if you not exactly, let's say, catch or implement the right case, your Ferrari will only run like, let's say, you are walking. That's it. Okay, so we don't care about industrial engineering, very important, but let's have a look on the master data. So the master data, which was rudimentary for the ERP, has changed. Now we have to discuss about E-bomb and M-bomb and a lot of bombs more. I have not in the pictures. 150% bomb. We have the E-bomb and we have material classification, configuration, we need configuration rules and all these things, and we realize, oh shit, all these master data has a life cycle and a time progression. And it is not stable anymore. It changes, and the change frequency is so hard that we really have to do anything, and if not, nothing is working. Okay. So you see, we change the PDM and the PLM, and the PLM goes all over it. And we have two life cycles. It's also important. We have a life cycle which goes, let's say, horizontal along the lifetime, and we have a life cycle towards the organizational data. Okay. And then also questions arise, you know them maybe. Where do we do configuration? Do we do configuration in PLM or in SAP or in a CPQ or in both? Thousands of questions. So anyhow, let's go to smart products, and you see, I could make it really, really complex. Let's just show on this, because there is another form of data, kind of data I will show you. So you know the V model, we start with requirements of a product, and then we pull it down until we know really the components of a product. So we have there a level where we really create master data, and master data, let's say in a granularity that we can push it to the ERP, and we have an emergence layer where we really emerge to the granulation, where we are rough, where we do, you will see functional system structures and physical system structures, and where the engineers are working. But anyhow, one point in time we have to be so clear that we are on a level of master data, so we can push the material through it, through to the ERP, and describes this. Anyhow, so we really can have another time a lot of discussion how this works. I can exactly explain, but what is important? There is a lot of change in the master data anymore. We have now engineering blocks, we have artifacts instead of documents, we have a lot of application data, we have the physical structure, the right thing, the functional structure, and all this thing. We have new classification stuff, and in the end we get more and more master data. Okay, then let's have a look on the ERP. So I think I have to make a short break there. Somebody calls me. No, I will not go and just will do the presentation. Okay, now let's go to the MES. What means MES? Just have a look on this picture. I think it says a lot, but let's talk about MES and how the big systems are working together in the future. How is the future interaction? So, first of all, the question is, why do we need a MOM and MES, and why do we need an APS? So there was a thinking that ERP can do all. Why we need other systems? And the answer is just simple. So you see this picture, and you see there is a ERP, and you can imagine it as a general. The ERP tells you in production what you have to do. And without an order from the ERP, nothing will happen. But there is a layer in between, because then you give, let's say, Tommy and Paul, and as the guys are named, name them, orders, and they have to organize themselves. The ERP does not do it for them, and they need, let's say, flexible, cool stuff, software to organize themselves. And this is what the MES does. And also they create a lot of data, and the data should be collected. This is also what an MES is doing. So just simple. And that means that in the past view, we have the ERP and underneath the MES, and there was a bit PDM. And let's say the king of all was ERP. What is the future? What is the future view? So let's think first about that we have this blue process in the PLM over the complete product development process. and that we have the MBOM which we really connect. So, and we have all these data which is also needed within the MES. And that means that we now have the PLM in the whole thing, over the whole process. We have the ERP and we have the MES. And typically we see that the MES get much more footprint and the ERP less footprint. And there are some reasons I will explain why this is happening. So the question is, what is the difference between an MES and an ERP? They do the same, they process the processes which are planned and indicates, I have to read this in MES as an ERP process. So it plans processes and initiates their completion and documents the completion. That is what the ERP is doing. But what is the difference? MES maps processes and time horizons more finely granular. Second, MES is more flexible, simply rescheduling is possible, and of processes easily possible. And third point, and this is important for us, the information model in MES is a technical model, not a financial oriented model. And this is very important. So in the ERP, the CFO is talking, and the CFO do not want a financial model, not a technological model. It's a complete different thing, and we can discuss it. In the end, you will see this with the resources. Typically, you want to have in the ERP resource blocks, which are, let's say, which share the same cost you have per unit. But you don't care about which they can do technically, can they do the same or not. So this is the reason why we have different, in the MES, different, let's say, structures which classifies your resources. And this is the difference. MES has a technological data layer. And in the end, we need data within the MES and its master data. And why not supplying the data directly from the PLM if this is created there? And that you can do this, a precondition is to have the MBOM in the PLM. If you do not have the MBOM in PLM, you cannot supply the MES. What does that mean? We will see it. PLM can be the king in the future and supply the MES directly, and it will has a dramatic change in the automation pyramid. We have the left thing, we have the ERP on top, and in the future we will have the PLM on top. In the end, be clear, the orders and the feedback of the orders has to come from the ERP, but the skeleton of master data will come in the future from the PLM. But only if you have the MBOM in PLM. If you have it not, then it is be created in the ERP. That means the MBOM is a gateway to MES. Without MBOM, you do not come to the MES. Just simple. Okay, now you understand these kind of picture. So let's have a quick look on some other things. New business models, what does it mean? Typically, you go to the service, we discuss about predictive maintenance, and we need product instance, we need customers connected to the product instance, we need digital twins as delivered, as maintained, all these stuff. Let's go on the next thing, just fast, customer journey. So we have a customer journey and say, how are the customer touch points with your company? How does it is experience with your company? And we want to have sales automation, because if the customer can find the products he needs on himself, your sales have more time to really focus on the big customers and help them. So this is the reason why we have sales automation. And if you look now on this picture, we have the first indicators that will happen. There's a lot of discussion about this in companies today. And we have only as first indicators the CRM systems and the CPQ systems. And if you now see this whole picture, then we can subsum all these things. So just have a look on this and see there seems to be a meta level, right? let's go just on the blocks. Here is a classic ERP, and here we told there is a PLM. And we have these blocks left and right. But these blocks left and right need master data. And this master data will in the future have also a life cycle. So it is consequent that we paint the blue box here. And what does that mean? All master data has a life cycle. We have a skeleton of master data. It gets more and more, and it's more frequently changed. And this is one of the most important statements I will do there. Every master data has a life cycle, has a time progression, and we have to manage this. So what does it mean in the sense of a system? We will have two system classes. We will have a system classes which creates and life cycles the information, and we have systems which use this information in the execution processes. That means you understand ERP system or MES don't care about modeling of information. They are not designed to model information or to lifecycle it. They just need it. And they have to get it from somewhere. So you need really, let's say, a layer where you develop the data, where you can handle all the changes, where you can put it together, and where you push it in the systems which are processes all the orders and all that stuff. And this is where we have the layer, and we can say then we will have an XLM layer in the future. And why it is not PLM anymore, it's an X. Why an XLM? Because we can put therein every letter. There is an application lifecycle management, then a configuration lifecycle management, organizational lifecycle management, all these stuff. We will have it in the future, and we will supply from there different systems, and we will really see how this get, let's say, the layer where we create that layer data, the layer where we put the layer down. And this is the blind spot, and I will, let's say, fix the blind spot. What do I mean? Typically today we see only this. We do big end-to-end SAP projects and we get the machine to run. But this machine needs gasoline, needs power fuel. And this power fuel, this machine gets not out of itself. It has to be generated. And if you do not have this information, the machine will not run at full power. And this is what I see overall. The problem is, since you ever are only driving your Ferraris on, let's say, on foot speed or pedestrian speed level, yeah, you do not really feel the difference. But imagine we solve the blind spot and we really care about all master data lifecycle and push all these lifecycle data in the right time to the system where the processes are flowing, then you can really go on full speed. And this is the reason why we need the whole thing. Okay, this is what we can say for today, but now we can go in the future and go to undiscovered territory and can say something on it. We see here two valleys. We go to the first valley, the XLM valley. So, and to go there, or to be able to go there, we should draw a map, and I will draw this map. Let's have a look on the future, let's say, setup of such a company. We have the real world where we have the physical object flow. Okay, and we have the information architecture of the system, and we have the ERP, which is the processing machine. And there we have all the value flows and all the volume flows. We have the CRM and we have the MES, and the ERP is supplying the MES with orders and say gives the feedback of the orders. And then we have the operation technology. We differ between the IT and the operation technology, and the operation technology are all the PLCs and the controls of the machine. And we have the APS, which really allows you to make the planning, the fine granular planning. And there will be systems, big IT system which we use to execute processes, but we will have a lot of systems which are there for information creation, information lifecycle management, and there we have the XLM layer, or we can call it the digital information architecture. And we know the MBOM is a layer, and we can push the MBOM directly in the APS, we can push it to the CRM, and then we will have the layer with IoT, which collects all the data and bring it back to the XLM system. And this is how the world will be tomorrow. That means XLM supplies the processing system with the necessary version-specific and time-correct master data. Today, PLM and LM can be seen as a result of the XLM. Otherwise, XLM is still undiscovered territory, and be sure, XML does not exist today. And then we can come with the black swan events, discuss about multidimensional disruption and resilience. So the XLM does not exist, and there arise a lot of problems because this problem is not fixed today. And now the people come and say, you need agility in the information architecture, and we have back our business consultant, and our business consultant say now, hey, just take low code and composable architectures, and the department makes their own thing, and then all the integration problems are solved. And this is also not true, or only half true, because the problem is, since we not fix the XLM, but it gets necessary to do it, and they say we have these old system monoliths, then let's say, some flexible things. So what does this mean? So you see then from the big consultant companies, first of all, the Gartner guys, these pictures, they say we had the monoliths, and now in the future we go to composable architecture, which meaning we took some data, we took some business capability, we took some API, put these together flexible in a low-code platform, and it works, let's say, like fairy dust. Anyhow, if we go further, then you are PLM architects here, and I think you will feel like this. But I think, and I'm really very critical about these composable application stuff, but I think there is a true core in it. The key is where we slice, because our XLM has different layers, and it's important to understand these layers. Let's look on the XLM. There is an execution near XLM. This is today done in the ERP, but we need an ERP near PLM layer to do this, and SAP has real cool stuff to do that today. And then we have an emergent XLM, meaning we have to emerge the data that they get the granularity that we really be on a level of master data. And if you look on the V, let's say, is perfectly there within, it's perfectly matched within these layers. And we have an application here, PDM, TDM layer. And there is another interesting thing. Since the vendors, the PLM vendors, which have the CAD systems, yeah, they put much more functionality in the CAD systems. And then they have to bring the PLM systems more to the applications. And it can be that, and I think at the Dassault system it is really so, that we have an application near PLM. And the question is, can one system fit all? And I think no, we will have different systems, composable systems, and do not forget, we will have more stuff. We will have a business partner lifecycle management in the future. We will have an organizational lifecycle management in the future. We have a content lifecycle management with all these unstructured information. We will have a knowledge lifecycle management where you really store all the knowledge in the head of your people within systems. This will come, and you see XLM will not be a classic monolithic IT system. XLM will probably emerge via distributed composable solution approaches. Anyhow, we can fix our landscape, our map, and it will look so. But there is another thing which is discussed today, and I will also show this. So you have heard about process mining, artificial intelligence, about product mining. This is the new stuff, I call it portfolio mining, and in the end you can subsum it as industrial data science. That means you have the discussion to do a data layer, and typically this data layer is, let's say, mixed up with the XLM, but it's not the same. And if somebody comes to you and say it's the same, it is not. So what will we have? We will have a layer above the whole thing, which I call industrial data science layer, and there we discuss this stuff with knowledge graph and data lake and data mesh. And all the other system will supply this layer. And today we have always this discussion about more and more dashboards, or you can analyze this and this and this. But I say to you, nobody likes to look on dashboards. It's absolute nonsense. For sure, you can in the future really, let's say, control the pulse of the company. You can really, let's say, have complete transparency about what happened, can create information you never imagined that is possible. We can do it today from the Steinbeis. We work on this. But in the end, we steer our company like we steered or controlled ships about 100 years ago with this kind of machine telegraph. You know this, the captain is there and puts on the thing, then down there in the machine room, voices are calling and crying, more coal, more coal. But this is crazy. You see, if you are today a CEO or a CTO, you have hold the thumbs and say, guys, I say to you, and please do it. I hope this will work. But this is crazy. We have to think complete on the other way. We can directly steer from this level a company, and we will see a fly-by-wire for companies for the main process. I'm quite sure, and this is working. Why I say to you, because we are really working at Steinbeis or at our Steinbeis center on this, and we are really far and can extremely clear explain how this whole thing should work. And now I come to the end and bring back the black swan. So what I wanted to say to you is that digitalization is not about implementing IT systems like PLM, ERP, MES or CRM. The goal that you should pursue is rather to implement the process patterns and the associated information architecture in your company in time, to gain the capabilities to respond agilely to the multidimensional challenges of an increasingly digitalized world, so that your company can survive in the future and also be successful for the long run. And XLM is the key. Have you expected this from the standpoint you had before my presentation? So that's it. I hope you enjoyed it. Thanks a lot for being there.